Let's practice working with parabolas. So before I jump in, please note that this is my second video on parabolas. So if you want to know about the bit about the definition of a parabola, a general talk kind of explaining the parts of a parabola, go see part 1 of this video. For this part, I'm just going to talk about using parabolas and using the table that helps us identify information about parabolas, as you see here, to help us solve problems. Okay, let's jump in. So notice that this table gives us a lot of useful information. It tells us the general or standard form for an equation of a parabola centered at the origin. It tells us the general form, whether it's horizontal or vertical, the direction it opens, the focus, the directrix, and the graph. Okay, so notice that P appears several times. P is when we're dealing with horizontal parabolas, which notice horizontal parabolas are not actually functions, they don't pass the vertical line test. When dealing with horizontal parabolas, P is the x value of the focus, negative P is the line that equals the directrix, and P is also part of the equation of the parabola. So if you know P, you know everything about the parabola. Let's practice. Okay. Let's say we want to write this equation in standard form for a parabola with vertex 0, 0 and the directrix x equals -6. What do we do? Okay, well notice first of all that they've told us directrix x equals -6. Directrix is defined by x. Notice that means we must have a horizontal parabola. Okay? Notice also that if the directrix is -6, well that means -6 is equal to -p. Because, see? So, if we divide both sides by -1, we find that p is equal to 6. Okay? Meaning 4p equals 24. In essence, we've been able to define, so this is the form for our equation, we're able to find that the equation is equal to x equals 1 over 24y squared, all because the only thing we had to solve for was p. Okay, so x equals 1 over 24y squared. Let's practice again. So we're going to write the equation in standard form for a parabola with vertex 0, 0 and directrix at y equals -4. Notice this time the directrix is defined by y, meaning y equals -p, so -p equals -4, meaning p, positive p, equals +4, meaning 4p, we're finding that because we're told to right here, 4p equals 16. So 4p equals 16, that's the one thing we have to fill into this equation, y equals 1/16 x squared. Let's do it again. Once again, we've got a vertex at the origin. Directrix equals y equals 3. So the directrix tells us that it must be a vertical parabola. So -p equals 3. Watch your signs here. Watch your signs. -p, y equals -p. So if y equals -p and y equals 3, then that means 3 equals -p, which means positive p equals -3. If you need to take a moment, pause the video, work out your signs really quick, I encourage you to do so. Make sure you understand where I got that from before you move forward. So if p equals -3, then 4p equals -12, and we're ready for our solution. Y equals 1 over -12 x squared. And it's as simple as that. The main thing we have to worry about is just figuring out if it's a horizontal or vertical parabola, so not getting tripped up there. All right, let's do it again. So directrix is defined by x. Right away that tells us that we've got a horizontal parabola. If x equals -7 and x equals -p, then that means -p equals -7 and positive p equals +7. If p equals 7, 4p equals 28, and there's our equation. X equals 1 over 28y squared. So can't stress enough that the only piece of information you need in order to fill in this equation is just what's p, okay? I think this is our last practice of this kind. So last time, we've got x equals -7 here, which means p equals 7. X equals -p, -7 equals -p, positive p equals 7, 4p equals 28, x equals 1/28y squared. Okay. That part's easy enough, right? So we've practiced identifying p. But what if they give you the equation? Notice that this is a lot more complicated than the equations we've been dealing with so far for parabolas. And we're asked to find the vertex, the value of p, the axis of symmetry, the focus, and the directrix. It's a lot of stuff to do. And notice that this isn't even centered on the vertex. The vertex is at hk, those coordinates we've become so familiar with, hk. So we have to identify first, is this a vertical or horizontal parabola? Well, it's got a y, it starts with a y, and then you see on the equal sign we've got a fraction and then an x something. If you notice, it looks exactly like this. So it's a vertical parabola. Notice that the format of this matches the format of my equation. So that means I can pretty much ignore everything on the left-hand side, and I'm going to focus on the stuff on the right-hand side of this table. Okay, let's do this bit by bit. So my vertex, hk. 2, -3. I got that by comparing, notice that they're doing x minus k, which means that y minus -3, that I identify as -3 is k. And then they've got x minus h. If I compare that to my x minus 2, I see that 2 is the x coordinate for my vertex. Be very careful with your signs here. It'd be really easy to accidentally write this as the -2, 3. Okay? So very careful with your signs. P, how are we going to find p? Well, remember, the denominator is 4p. So if my denominator is 8, 8 divided by 4 is 2. My axis of symmetry is right here. It says x equals h. Well, I already found h, didn't I? It was right here because my vertex is hk. So I already know it. My axis of symmetry is 2. My focus looks like it's defined by h, k plus p. H, k plus p. Well, my h, as we know, is 2. My k is -3, but I'm going to add p, which is 2. So that's 2, -1, because -3 plus 2 is -1. Finally, my directrix is equal to, it says y equals k minus p. K minus p. So k is -3, p is 2, so -3 minus 2. My directrix is -5. So every bit of information you need exists on the table and in the equation. Let's do this one more time. So I've got my equation. I'm going to find the vertex, p, axis of symmetry, focus, and directrix. Okay, so it's as easy as reading this chart. First, are we horizontal or vertical? Notice I start with an x minus construction. On the other side, I've got a fraction with a y minus term. That seems to match horizontal perfectly. Okay? Now, let's start with vertex. So my vertex is hk. My vertex is hk. So h comes from here. So since I'm subtracting 1, my h is 1. My k, y minus 3, my k is 3. P is equal to, let's see, 4p. So if I compare this to my denominator, that means that 4p equals 12, so p must be equal to 3. My axis of symmetry. Well, let's see, my axis of symmetry right here, this is the only one we have to consult the photo for, y equals k. Well, I already found k. K is equal to 3, so my axis of symmetry equals 3. Focus. Focus is h plus p comma k. H is 1, p is 3, so h plus p, and k is 3. So I get 4, 3. Finally, my directrix is h minus p. H is 1 minus p is 3. My directrix, x equals -2. So I really encourage you to find an equation somewhere in your course player. I'm sure there are questions on this. And just practice identifying the parts. As you can see, it takes very little calculation. It's just a matter of matching up pieces of your equation to pieces on the table. So with a little practice, you'll get this down.